Welcome. Today I will talk about the gravitation and inverse square law. So, I will start with a little bit historical background. I will talk about first of all Galileo, and then I will talk about Isaac Newton. So, yeah, this is a very important, very interesting figure. It's a leaning tower of Pisa. This is the figure which I have taken, and this is the old idea, and this is the Galileo's idea. And let me talk about this. That what does it mean? And it's a very interesting idea. Yeah. So, so what Galileo did earlier, it was assumed that when two objects of say different masses are thrown from certain height, then we found that the heavier one will fell down and the smaller object will fall later, means it will take more time to fall down. So for example, in general, if we took a feather or a paper, and if we take a ball of iron, it's a ball of iron, and if both are dropped from a very certain building from the height, then we in general we found that the paper will drop later on and the iron ball will fall down and reaches the ground first. That's a very simple observation. So but a very interesting experiment means which was performed by Galileo, and let me talk about what was that experiment. That he dropped two unequal weights. It's a very important interesting experiment. He has taken two unequal weights of same material, and from the leaning tower of Pisa, and the height of the leaning tower is basically this is 56.67 meter on one side and 55.86 meter on the second side, another side, means the leaning side. So this is the old idea, old concept, and what he found, that when the two objects of same material and same shape was dropped from the same height, both will reaches the ground at the same time. So that means their motion is independent of mass. And how much distance they have traveled, that distance traveled with time, that is basically equal to half at square, and a is the acceleration. And Galileo was the first who basically introduced the concept acceleration and the distance traveled, and he basically incorporated certain type of equation, and this equation was shown here into the physics. Means he is the first person who tried to incorporate mathematics into the physics, right? So this is a very interesting experiment performed by Galileo. Now he also performed various experiments, inclined plane and motion of inclined plane and the motion of objects, and Galileo conducting the experiments using a ball on an inclined plane, and determined the relationship between the time and the distance traveled. And distance traveled dependent upon the square of the time, means distance traveled is comes out to be proportional to the square of the time, and velocity increases as ball moves down the inclined plane. Means initially it is moving with a very small velocity, and when it keep on moving downwards, then its velocity keep on increasing slowly and steadily, and this change in its velocity is equal in equal interval of time, and the relationship was the same regardless of the mass of the ball used in the experiment. And again he find out this relationship, that is, it is equal to half at square for the inclined objects. Again the similar type of expression he got it right. And then he also performed another very interesting experiment in the concept of inertia. And earlier it was assumed that, or he challenged the Aristotelian view. Aristotle believed that force was necessary to keep an object moving. Earlier it was assumed that. But what Galileo counter argument? He said that object tends to maintain their state of motion either at rest or moving with a constant velocity unless something interfered with them. This was the statement given by Galileo. And to support his argument or support this fact, what he said, say he thrown a ball here, and when he throw it here, then it reaches the same height. And again, when he thrown ball like this, he again reaches the same height, and so on. Means its slope keep on increasing, but again the ball reaches the same height. It's not exactly, but nearly the same height the ball reaches. So on the basis of this experiment, Galileo confirmed that object tends to maintain their state of motion either as because we are not applying the force over it and it has certain energy, and with that it again reaches at this point again the same height. But earlier it was said that some external force is needed to make that motion, make the object moving. But if here I am not applying the force, and without application of the force ball reaches at this height, it's the same height, right? So these type of experiments leads to conclude that Galileo that when body is rest and it will remain in the rest, and when it is moving with the constant velocity it will remain unless it is interfered with them, right? And this is basically the law of inertia. So the law of inertia was first given by Galileo, and this was again given by Einstein, or in other words we can say that this is basically the idea of the Galileo is the law of inertia. So what is Newton's laws? That Newton refined the Galileo's idea of inertia and states law of inertia, and every object continues in the state of rest or in the state in form speed in a straight line unless it is acted upon by the net external force. So this will remain same as it was given earlier. Let me show you some just a minute here, let me show you some. Sure. See, this is a very simple experiment. So see, in this experiment the coil is at the rest on the top of this card, but when we flip on the coin, what will sorry, not flip on the coin, but when we flip on the card will move upward, but the coin will drop down as shown here. So coin drop into the glass when the force applied on the card, means coin will not move because we are not applying the force over the card. We are not applying the force over the coin, so that means coin will not move with the card, but card will move out and the coin will down into the glass of water. This is a very simple experiment to show law of inertia. And then let me talk about Newton's second law of motion. So Galileo's inclined plane or the free fall body experiments, what they conclude that objects accelerate at a constant rate under the influence of gravity, and there is a link between force and the change in the velocity. Heavier objects require more force to achieve the same acceleration as lighter objects. So what this recognizes that the mass as a measure of the object's resistance to accelerate, means it is inertia. And another thing is that it deduced that acceleration is directly proportional to the net force applied and inversely proportional to the mass of the object. So these are the few things. If I try to look at all these facts, the Galileo's inclined plane experiments, there is a link between the force and the change in the velocity. More force is applied, more velocity changes. And in the same way, there is a relation of the mass with the applied force, because it's easier to accelerate the lighter objects, and it becomes very difficult to move the heavier objects. So that means there is a type of relationship between means applied force and the mass and the change in the velocity, and change in the velocity is basically acceleration. So keeping all these things in mind, Newton deduced the law that the force is equal to mass into acceleration. So this is a mathematical formulation of this, right? Or in other words, we can say that all these observations deduce that acceleration is proportional to net force applied and inversely proportional to a mass object. And if I club these two, say if I try to look at it, that acceleration is proportional to applied force, and acceleration is proportional to inversely proportional to the object mass. So that means if I bring this here, so that means or I can say that in other words that this force is proportional to acceleration, and here I can write, I bring it here and here, so mass is proportional to, or mass is proportional to this is this. So if I club these two, then I can write down that the force is proportional to mass and the force is proportional to acceleration, right? So in other words, I can say that force is proportional to mass into acceleration, and right. So then let me show you another very interesting experiment, or interesting law, that is the Newton's third law. This is a very interesting experiment. Say I have taken two balls, and let me do one more thing. Say I brought these, means मैंने क्या किया, मैं इनको थोड़ा सा एक दूसरे से दूर लेके गया, and then I released it. So if I initially look at it, so both the balls again attaining the same distance as in the beginning, and after that, due to the say sound, and there is an interaction between them, so there are so many things of the resistance offered by the air, because of that their motion will die off. So there are certain examples. Say what was the examples? Let me talk about the example of muskets and the cannons, means bandukeं और तोपें. So cannon means तोप. So earlier depiction of cannon is a sculpture from the Daju rock carving in the Sichuan, dated in the 1128. Means 1128 में किसी रॉक पे कार्विंग की हुई थी, वहां पे तोप का फोटो बनाया हुआ था, राइट? तोप का फोटो बनाया हुआ था, और फायरिंग फ्लेम्स थी, वहां से आग निकल रही थी. This cannonball is going outward. So एक चट्टानों के ऊपर कार्विंग करके तोप का फोटो बनना 1128 के आसपास. So इसका मतलब क्या हुआ? इसका मतलब ये हो कि तोपों के बारे में उस टाइम भी लोगों को जानकारी थी, right? So and another first recorded uses of the term musket, means bandukeं, appeared in the Europe in the year 1499. So that means बंदूकें और तोपें उस टाइम एक कॉमन सी चीज थी. And then another example is the rowing and the sailing, because what will happen जब हम तोप के अंदर गोला डालते हैं तो उसके ऊपर एक पिछली ओर एक जर्क लगता है, उसी तरह बंदूक में जब बुलेट को फायर किया जाता है तो जो बंदूक है, मींस जो गन है, दैट कम बैकवर्ड, दैट कम्स लिटिल बिट बैकवर्ड, उसके ऊपर फोर्स लगती है। सो दैट मीन्स एक फोर्स उसके ऊपर आगे लग रही, जैसे बुलेट आगे जा रही थी वैसे ही वो गन पीछे आ रही है। इसी तरह तोप के केस में भी ये हो रहा था। तो उस टाइम, मतलब न्यूटन के टाइम पे या उससे पहले, इस तरह की चीज़ें कॉमन ऑब्जर्वेशन में थी। रोइंग एंड सेलिंग मीन्स पाल नाव जो होती है, बोट जो होती है, उससे लोग एक जगह से दूसरी जगह पानी के थ्रू ट्रांसफ़र करते थे। स्विमिंग में हम क्या करते थे, स्विमिंग बड़े पहले से हमें पता था कि जब भी हम स्विमिंग करते हैं हम पानी को बैकवर्ड डायरेक्शन में धकेलते हैं और हमारी बॉडी पानी में आगे की ओर जाती है। सो दैट मीन्स जब फोर्स बैकवर्ड डायरेक्शन में लग रही तो एक फोर्स फॉरवर्ड डायरेक्शन में ऑटोमेटिकली लग रही थी, मीन्स फॉरवर्ड एंड द बैकवर्ड। या ये बोल सकते हैं कि जब हम एक डायरेक्शन में पुश कर रहे हैं, धक्का दे रहे हैं, तो एक डायरेक्शन, वो चीज़ हमारे ऊपर दूसरी डायरेक्शन में भी धक्का दे रही थी, जैसा हम स्विमिंग के टाइम पे देख रहे हैं। रोइंग और सेलिंग के टाइम पे मीन्स जब चप्पू चलाते हैं बोट में तो तब भी यही चीज़ होती है। और बंदूकों में और तोपों में हम वो देखने को पहले से मिल रहा था, क्योंकि वो ऐसे कुछ एग्जाम्पल्स थे हिस्टोरिकली। सो दैट मीन्स व्हाट न्यूटन डिड, न्यूटन इन सारी ऑब्जर्वेशन को क्वांटिफाई करने की कोशिश की। एंड ही सेड दैट फॉर एवरी एक्शन देयर इज ऑलवेज इक्वल एंड अपोजिट रिएक्शन। सो दैट मीन्स अगर सेकंड ऑब्जेक्ट फर्स्ट के ऊपर ये फोर्स लगा रहा था, देन फर्स्ट ऑब्जेक्ट सेकंड के ऊपर ये फोर्स लगाएगा, बट इट्स इक्वल एंड अपोजिट, बट इन द अपोजिट, sorry, it is the equal force but in the opposite direction. So this is the Newton's third law, right? So this is it. So in conclusion, what I trying to say that Galileo's primary focus was on the motion of single object, particularly those under the influence of gravity, and his experiments with the inclined planes and the falling bodies led him to understand inertia and uniform acceleration. उसी तरह से न्यूटन हैज गिवन ए ब्रॉडर स्कोप, न्यूटन्स वर्क encompassed a broader scope and including not just the motion of individual objects but also the interaction between them, and this is where the third law comes in, right? So this is all for this lecture, and in the next lecture I will talk about some more concepts, that is basically I will talk about Newton's law of gravitation, that how idea of Newton's law of gravitation will came and how Kepler helped him. So that's all for this lecture.